Hello, and welcome to our last lesson of week 4, solving multi-step equations. So the learning target for today is we're going to be able to combine like terms and use the algebraic properties of equality as well as the reverse order of operations to solve multi-step equations. So we're going to use a lot of different tools that we've learned so far to solve more complex equations. So let's take a look at the first one here. So we've got 3x plus 7 minus 5x plus 12 equals 41. It's a lot more there on the left-hand side that we haven't seen before, or have we? Well, right now we have two x's. That can make it a little tricky. We haven't seen that yet when it comes to equations. So what do? Well, we have learned how we can combine like terms and expressions and come up with an equal expression on the left-hand side there. So we're going to do that. We're going to simplify the expression by combining like terms. Well, my like terms here are 3x and negative 5x, also 7 and 12. So we're only looking at the left-hand side right now. We're not looking at that 41. So if I combine 3x and negative 5x, I get negative 2x. And then 7 and 12 are also like terms. I can put those together and make 19. Now I've simplified 3x plus 7 minus 5x plus 12 into negative 2x plus 19. Those two things are equal. Notice I haven't done anything to the right-hand side yet. Now I'm at a point where I can do that. I can now go back to what we learned in the last lesson, and we can move the 19 to the other side by doing the inverse operation. So subtract 19 from both sides. That leaves me with negative 2x equals 22. And now I have to undo that multiplication of negative 2 by dividing by negative 2 on both sides, and I get x equals negative 11. Now, something I haven't talked about. There is a way to check your answer. We did a lot of work there. It's possible we might have made a silly mistake. It's a good idea to check your work. Well, how do I do that? Well, I take my answer that I got, so negative 11, and I plug it back into the original equation, so the very first equation, anywhere I see an x. So I'll show you what that looks like down below. This is how I check it. So I do 3 times negative 11. I replaced x with negative 11, plus 7, minus 5 times negative 11, plus 12. And we're going to see, does that left side simplify down to 41? I don't mind if you use a calculator here. Make sure you type it in correctly. Or you could just do some mental math. So 3 times negative 11 is negative 33, plus 7. Negative 5 times negative 11 is positive 55, plus 12. And now I just add those numbers up, and you get 41, which is equal to 41. And that's a way of checking to see if I did all my work correctly. Example 2, the distributed property. We've done this before. We're going to use that first to help us undo those parentheses, really, is kind of what we're doing here, so that we can move things around and get x by itself. So I'm going to distribute the negative 4, which gives me negative 12x, and then negative 4 times 6 is negative 24 equals 12. The negative 4 does not go with the 12. All right, so I'm going to do the inverse operation with subtraction of 24. So add 24 to both sides, and that gives me negative 12x on the left and 36 on the right. Divide by negative 12, and I get x equals negative 3. Let's go ahead and check it by plugging that in. So negative 4, 3 times, instead of x, I'm putting negative 3 plus 6, and we're going to simplify that left-hand side, and we'll see if it equals 12. Well, 3 times negative 3 is negative 9. Negative 9 plus 6 is negative 15. Sorry, negative 9 plus 6 is not negative 15. It's negative 3. And then negative 4 times negative 3 is 12. A little more challenging problem here. There are ways of doing this that are not what I'm about to show you. I highly recommend understanding what I'm about to do. I'm going to clear the fraction. So I've got a couple fractions going on here. I want to multiply both sides by the least common denominator. So if I were to change that first fraction and second fraction to have the same denominator, what would that denominator be? Hopefully you see that it would be 8 here. So I'm going to multiply both sides by that 8. Notice what I did there. I'm multiplying that whole left-hand side by 8, and then I have to multiply the 5 by 8. What that does, well, let's distribute the 8. 8 times n is 8n. divided by 4 is 2n. 8 times 3n is 24n, divided by 8 is 3n. So I've got 2n plus 3n equals 5 times 8, which is 40. I've just simplified the left and the right. Almost. 2n plus 3n is 5n. So I'm going to go ahead and combine like terms, and I get 5n equals 40. Now it's a divide by 5, n equals 8. You could go back and check your work by putting 8 in for n. I'm going to save us some time and not do that, but you could to see if it gets you the same answer. And just like clearing fractions, we can clear decimals. So you see that in this problem, we have multiple decimals. We got 4.6 minus 0.02x equals 1.32. I see that I have to move the decimal point 2 spots. That's the most I have to move it. So in that middle term and the term on the right, if I move the decimal 2 spots over, I would have it at the end of each of those. Well, how do I do that? You're basically multiplying by factors of 10. If I have to move the decimal spot one point over, or one place over, I multiply by 10. If I have to move it 2 places over, I have to multiply by 10 twice, or by 100. Now you might be thinking, well, I only have to move this one once and this one twice. You have to take the biggest. So I'm moving this one twice. I have to move all of them twice. So that's what I'm going to do. I'm going to multiply both sides by 100. So 100 times 46 is 460. 100 times negative 0.02 is 2x. And 1.32 times 100 is 132. I have an equation now that I should be able to solve. I'm going to move the positive 460 to the other side by subtracting it from both sides. And that 460 minus 460 gives me 0 and leaves me with negative 2x. 132 minus 460 is negative 328. Last step, divide by negative 2. I get x equals 164. And again, you could plug that in to check and see if you did that correctly. And that is the end of this lesson. Congratulations.